Now I'd like to give you some more information on the subject of level 2 of TROM. Now, level 2 is the level which is devoted to finding differences and similarities between then and now. And I'd like to give you some more information on this subject of differences and similarities, in order that it may be of assistance to you when running level 2. When we look up the word difference in the dictionary, we find that the dictionary defines a difference as a non-identity. In other words, the dictionary is saying that if two things are different, then they aren't identical. Now, this definition of a difference in terms of a non-identity isn't very useful to us. For the following reason: it's well known in science that to define one thing in terms of the absence of another never leads us to a useful definition. All good definitions of things are when we define a thing in terms of something else. When we define a thing in terms of the absence of something else, the definition is hardly useful to us at all. The reason for this, there's an excellent logical reason for this, that when we say that two things are different when they are not identical, then we're faced with defining non-identity in logic. Well, we can define non-identity in logic. It's not a difficult thing to define, but unfortunately it doesn't lead us to equations which we can easily manipulate. It leads us to what we call in logic inequations. What's called an inequation. We end up with something which is not equal to naught, something which is not equal to zero. And such equations are very, very difficult to manipulate, very difficult to manipulate in logic, and aren't particularly useful at all. So, if at all possible, in science, we always try and define something in terms of the existence of something else, and if only because such a definition is useful. It can be useful to us. Now, my feeling on the subject, I have a gut feeling on the subject of defining a difference as a lack of identity. In other words, to say that two things are different if they aren't identical. I have a feeling here that this definition has been rolling down the time track in the Western world for some few hundreds of years. And I think it probably started back in the Middle Ages sometime, or maybe 1700, something like that, when somebody said, well, we ought to be able to define a difference. And he looked across and said, what do you think, Bill? And Bill thought about it for a moment and said, well, he said, if two things are different, they aren't identical. And that's a good definition of difference, isn't it? And the other person says, yes, right, well, we'll put that into the dictionary. And it's been in there ever since. Nobody's queried it. Nobody's really thought about it much. It's been reprinted from edition to edition to the dictionary. And it looks all right. The only thing is that it's just about useless from a scientific point of view as a definition. It's just about useless. You simply can't use it as a definition. Now this situation prompted me recently to look into the subject of differences. and look into it on the track and in the universe in general. And I quickly realised that there's more to this subject of differences than meets the gaze. There's a very early game on the subject of differences in this universe, which pops up as soon as you start to look at it. This is the way it works. You've got these two spiritual beings very early on in the universe, you see, and one of them's got these two mock-ups. One's called, shall we say, is called A, and the other one's called B. And he's saying to the other person, now what they're talking about these two mock-ups, you see, and the person says, the owner of the mock-up says, they're quite different, of course, aren't they? And the other being, the other spiritual being, says, well, he says, I don't see as how they're different. And the first person says, well, he says, they're obviously different. And the other guy says, well, I don't see as how they're different at all. Now, what the first person, the owner of the mock-up, doesn't realise is that the other guy's playing games with him. The other guy can't quite clearly see the difference between the two mock-ups. But in order to play a game, he's saying that they're not different. In other words, he's saying to the owner of the mock-up, he's saying, prove it. He's saying, prove that they're different. See? Like the other guy has to go away and think about this. He said, well, now, how can I convince this other person that these two mock-ups of mine are actually different from each other? So he gives it some thought, and then he finally realises how he can solve this problem. So he goes up to having solved the problem, he goes up to the other guy and says, right, he says, now there's these two mock-ups of mine here, you can see how they're different. And the guy says, no, he says, I can't see how they're different. He said, well, he said, here's mock-up A and here's mock-up B, you see. He said, now, you'll notice that mock-up A possesses this quality X. And the other guy nods and says, yes, I do see that. He said, well, now, there's mock-up B over here does not possess this quality X. Right? The other guy admits it, yes, he said, that's quite true, that mock-up B over here does not possess this quality X. So therefore, says the owner of the mock-ups, says the two mock-ups are different. The other guy thinks about it for a moment and reluctantly has to admit, he says, yes, he says, you're right, he said, they are different. He said, if A possesses this quality X and B does not possess this quality X, then A is different from B. Now, there is the proof. There is the proof, and there is the game of differences in the universe. The game is simply that in order to establish that A is different from B, one has to establish that A possesses some quality, call it X, and B does not possess this quality X. And having established that, one has now established that A is different from B. And by established that A is different from B, I mean one has proved it. One has proved it against all comers. Now, if you think about this for a moment, you see that this is a very excellent definition of a difference. That this guy early on in the universe had actually defined a difference. He defined it. In order to have to prove it, he defined it. And we can define a difference in that way. And it's a perfectly workable definition. We simply say that A is different from B if A possesses a quality X and B does not possess this quality X. And by reverse, if A possesses this quality X and B does not possess this quality X, then A is different from B. See, it's a beautiful definition. And note that it's a definition in terms of existences, and it's not a definition in terms of absences. Well, now, it would be very useful if we could reduce this state of affairs to some logical propositions, and develop some equations on the subject, wouldn't it? We would then have a very workable definition of difference in the universe, and would be able to compare this definition with what it says in the dictionary. So let's go ahead and do this. Now, when we say that A possesses this quality X, we only mean that the proposition if A then X. That's all we mean when we say that A possesses a quality X. We only mean that the relationship if A then X holds. And when we say that B does not possess a quality X, then all we mean is that the relationship if the relationship if B then not X holds. Now it's very easy to manipulate these two relationships, reduce them to symbols and so forth, and arrive at some equations which represent this definition, which represent the universe of this definition. Now I won't bother you with just how one would feed this material into the logical sausage machine and turn the handle and get the answers out. Well, I can assure you that the answers that you get out are quite valid. And the answers come out like this. First of all, we have the common class, both A and B. Well, that common class is a null class. It doesn't exist. AB is a null class. Then we have the class of I, that is the common class of A and not B. Well, every time we see this class of A and not B, we see this property, this quality X. Then we get the class of B and not A, and every time we see this class, we see the property not X. Finally, when we see the class of neither A nor B, it's indeterminate. We can either see the property X or not see the property X. It's quite indeterminate. And that is our universe. That is our universe of our definition. Now, the first thing we would like to know is that how does this definition compare to the definition given in the dictionary that two things are different if they are not identical? Well, it's they're very close. They're very close. Actually, our definition is just a shade stronger, that's all. It's just a shade stronger. The only difference between our definition and the definition given in the dictionary is that we are very definite and very positive that if A is different from B, then this common class of both A and B does not exist. Whereas the dictionary definition, where it says that if A is different from B, then A and B aren't identical. That definition does allow the common class of AB to exist. So that is the only difference between the two definitions. Ours is just a little firmer, and it certainly includes the dictionary definition, but ours is a little bit stronger, just a little bit stronger. We now have to ask ourselves, are we justified in taking this extra step? I mean, is it true? Is it so that when are we justified in saying that if two things are different, if A is different from B, then the common class of AB is null, and that these two things have no common class? Well, common experience tells us that yes, we are. We are quite justified in doing this. So therefore, our definition is correct. And the definition in the dictionary isn't strong enough. It's simply not quite strong enough. It's almost right, the dictionary definition, but it's not quite strong enough. The two fellas playing the game back at the early on in the universe, they got it right. They got it right. By proving the difference, he defined it. And by using that proof, we come up with a workable definition of a difference. So let's just comment on that a little further. Quite clearly, if two things are different, then if A is different from B, then quite clearly, every time you see A, you don't see B. You follow that? In other words, they can't have a common class. If A is different from B, then every time you see A, you don't see B. And every time you see B, you don't see A. Because they're different, you see. And that really does define the difference. That is the essential quality of the subject called difference, is that they have no common class. Now, if you know that about differences, if A is different from B, then the common class of A, B is null. They have no common class. You understand more about differences than the guy who wrote the dictionary, because the dictionary definition doesn't include that. The dictionary definition isn't strong enough to give you that. But our definition of a difference is strong enough. And what is our definition of a difference? Right, well, here we go. If A is different from B, then A possesses a quality X and B does not possess that quality X, and vice versa. And that is our definition of a difference. We define it in terms of this quality X. Now, as soon as we define our difference in this way, immediately things start to, the definition is useful, immediately starts to become useful. Now, before going on to talk about the usefulness of this definition, I'd like now to go in and discuss the definition of a similarity. We ought really to run these two parallel together. So we'll now talk about the subject of similarities, then we'll tie up the whole subject. Now, when we consult the dictionary on the subject of similarities, we find that the dictionary says that if A is similar to B, then A and B are alike. Well, when we come to examine this, we find that this is so. I've researched this back on the track, and this is so. And what we really mean when we say that A and B are similar is that they have something in common. And that is the essence of similarity, is that the two things possess something in common. They share some quality. They share a quality, or they share a property. And that is what we mean when we say that the two things are similar. Now, this is exactly in accordance with the dictionary. So there's no variance at all in our definition in TROM for a similarity as compared to the dictionary. There's no variance at all. We're completely in line with the dictionary definition there. So what would be our definition? We can give a very, very precise definition of a similarity. And what would our definition in TROM be of a similarity? Well, here we go. If A is similar to B, then both A and B possess this quality Y, and vice versa. Now, again, putting those propositions, reducing them to symbols and pushing them through the logical sausage machine, we end up with a universe that looks like this, that every time we see the common class of both A and B, we see this quality Y. Every time we see the common class of A and not B, we see this quality Y. Every time we see the common class of B and not A, we see this quality Y. And every time we see the common class of neither A nor B, it's indeterminate. We don't know whether we see the quality. We may see the quality Y, or we may not see the quality Y. So that gives us our universe of the similarity. Now, as we examine the subject of differences and similarities in terms of our definitions, we're struck at once, we see at once that any two objects, any two things in the universe can be both different and similar simultaneously. And further than that one would be hard put in this universe to find two objects that that weren't both different and similar. In other words, as you examine these two things, you would start to see differences between them, and you would start to see similarities between them. Only if you had two objects that were completely identical would you see a different set of circumstances. But look, you don't find two objects in this universe that are utterly and completely identical, because all the objects in this universe are separated out in space. The mere fact that two objects are occupying different positions in space means that they're different. They're in different positions. We have a quality X, you see, different location in space. So if two objects are in different locations in space, they're different by definition, by our definition of difference. So we don't find, as Ron Hubbard used to say, and said on many occasions, that this universe is stretched, that everything's stretched out, that we don't find two objects in the universe that are actually identical to each other. In this universe, the only thing that a thing is identical with is with itself. And that happens to be the truth of the matter in this universe. So, in summary, we now have our definition of a difference, and we have our definition of a similarity, and we've discovered that all the objects you're likely to come across, if you examine them closely enough, all the objects in this universe, if you examine them closely enough, you will find that they do possess differences, and you will be able to find similarities between them. And as a final rider, that you won't expect to be able to find any two objects in the universe that are identical. If you do find that any are identical, just bear in mind that if they're in different positions in space, they aren't identical. Right, well now, between the then object and a now object, we're saying that these two objects do not possess a common class. Bear in mind that is the essential part of a difference. If two things are different, their common class is null. They do not have a common class. So we're separating all the time. Every time we're doing the command at level 2, the difference command, we're separating out all the time. And we're running the similarities simply to keep the flow balanced. That's all. If we were to keep going on differences all the while, the flows will become unbalanced. So we go over to the similarities to let a person see that the two things can not only be different, but can also have similarities too, and to balance the flows. So backwards and forwards we go. But all the time, we're separating out then from now and saying that now and then have no common class. And by saying this, and get this, and this is the essence of it, by saying that, we are breaking the command power of the past over the present. In other words, we're just kicking at the reactive bank and the command power of the engrams, and the whole idea that the past has a command power over the present. By finding differences and similarities between then and now objects, the person is literally taking over the automaticity of their reactive bank. They're taking over that they themselves are able now to bring things into the present and take them out of the present, noticing the differences and similarities there. So they're taking over the complete automaticity of their own bank. And so, of course, the bank just collapses, because now the person can do consciously, analytically, that which their reactive bank used to do. So, of course, the reactive bank just fades out of existence. And that is level 2. And that is precisely why it works. Well, I hope this material you will find of assistance and to give you an added reality and increase your reality of level 2 of TROM. Thank you very much.